Let us have a quick overview on the container orchestration platforms and the auto-healing and replicas features. Kubernetes is a container orchestration platform that enables deploying, scaling, and management of containerized applications. And OpenShift is an enterprise grade application platform that is built on top of Kubernetes. We are able to see a number of projects here. Let us go to the project COM IBM MDM1. The basic unit that comes to us when we are deploying applications is the pods. A pod is essentially a combination of one or more containers and an optional list of volumes. The MDM operational server is a stateless container, and hence we do not have any volumes associated with it. When we come to a pod, we are able to see certain details corresponding to the pod, namely the deployment to which it is associated, an IP address and node which are associated with it when it gets deployed, a restart policy which is a value that we specify, and certain other properties. We are also able to see the container, the image that is associated with the container, the command that is used to start this container, and the ports that are exposed from this pod. We can also see the CPU and memory related parameters and something called as the readiness probe and the liveness probe. All these values are provided only as samples from MDM and can be edited before deployment by the customer. If we go to edit YAML, we are also able to see these properties here, and these properties have been provided when the pod was created, when the deployment was created rather. These values can be changed based on the customer requirements and the environment in which the pods will be running, the MDM will be running. Now let's do one thing. We are able to see here that the container is up and running. The server is open for e-business. Let's log into the terminal and stop the application server. When we create the pod definition, we have added something called as the liveness probe. And the liveness probe here checks whether the application server is up and running by checking whether it can access the server at port 9043. Let us see what happens when the server is stopped and what the liveness probe does for us. When the server has stopped, we see that the terminal has been disconnected, and it's not possible for us to connect back again to the same container. When we go back to the list of pods, it is possible for us to see that the pod that we were accessing is now having a container restart, and the entire container is being started again and that this container is not yet ready. It shows us that 0 out of 1 containers is ready. It is because this container is being started now once again. It has been removed and it has been created from scratch once again. We have given a property, the minimum time for the container to get ready, and that is 2 minutes. Until then, this will show us that the container is not ready. So we see that the system is brilliant enough to find out whether the container is ready or not ready and to take a corrective action as required. Let us do one more thing. Let's get into the other pod and let's delete this pod. When we delete this pod, we see that the pod status is terminating. However, we are able to see that another pod is being created. This is because on top of the pods, we have some supervisors, namely the replication controllers and the deployment config when it comes to OpenShift, and the replica set and deployment when it comes to Kubernetes. So with the replication controller and deployment configuration in place, it is possible for us to mention the number of replicas. It is saying that it is scaling to 2 replicas because the desired number of replicas is 2. We will also check what autoscaling means for us. Since we have mentioned that the required number of replicas is 2, the system is capable of figuring out that 2 replicas are not existing, and it automatically creates a new replica when one of the pods go down. Here we manually deleted the pod, but there are cases in which the entire node could go down. In all those cases, we need not bother because a replica will automatically be created in one or the other node whenever the number of replicas is not available. This is an added feature in Kubernetes and OpenShift which allows us to be reliant on the system that the number of replicas will always be maintained.